So you're interested in understanding the biggest problem physicists have been obsessed with for decades, the theory of everything, or more specifically, the theory of quantum gravity. So what exactly is quantum gravity? Well, first we need to know two components to this theory, relativity and quantum mechanics. You've probably heard the famous theory of general relativity proposed by Albert Einstein. It explains that instead of the force Newtonian physics suggests gravity to be, gravity is actually a result of the curvature of the fabric of space-time. That's a pretty heavy sentence, so let's break it down a bit. Newton said that a force equates to mass times acceleration, so if you push your friend, you just exerted a force on them and probably made them a bit angry, except that's not entirely the case with gravity. Picture a trampoline, a ball placed in the center, and a marble. The ball causes a curvature and in turn results in a force that pulls the marble down in the center. Without the curvature, there wouldn't have been any pull, or gravity. This tells us the presence of mass or energy causes a curvature of space-time, which results in the force of gravity. In quantum mechanics, a fundamental principle is superposition, which is where a particle can exist in several states instantaneously. But once observed, one state is measured. Think of a day where you needed to be at several places at once. Maybe you had a doctor's appointment, a party, and an exam all at the exact moment. If you were operating according to quantum mechanics, you could be at all those places at the same moment. Except if your mom opened Life 360 and checked your location. She would then observe one location. And let's hope it's not the party. We now get the basic theories. So why not just combine them? Well, it's more complicated than that. Out of all the forces that govern our universe, gravity is the weakest. At the quantum scale, it's almost weak enough to be negligible, except in some instances, its effect should be seen. Remember superposition? The orbit of an electron around a nucleus uses this concept of existing simultaneously in different positions. And if you remember that the presence of mass or energy causes curvature, which then causes gravity, and we know electrons have mass, then there should be a curvature. But when an electron is in a superposed state, where should the curvature be? And what about points of infinite density, space-time singularities? Turns out Einstein's equations that describe these curvatures completely break down. Currently, the most promising theory of quantum gravity is string theory. It proposes that elementary particles are composed of tiny strings, and a certain vibrational pattern accounts for different elementary particles. For example, a certain speed of the string would create a quark. This suggests the existence of a hypothetical particle, the graviton, something that theorists believe could explain quantum gravity. However, as of now, it's untestable. Until then, we can keep observing and questioning. And who knows, maybe you'll be the next physicist to propose the true theory of everything.